Topic for today, everyone, is electrophilic addition, and there's two examples to consider. So the first one I'm going to do myself and explain how it works. And then the second one you are going to try once you've watched the video and taken notes, and then you can check your answer using the answer scheme I've attached at the bottom of the video. So let's get into this first one. So just some general notes first of all about the mechanism. So the main thing is electrophilic addition tends to take place in unsaturated compounds. Okay, so that could be alkenes, even benzene, alkynes with a triple bond, and so on, where an electrophile, which is an electron deficient species, adds to something that is unsaturated, like a double bond. So the electrophile that's been added, what you will see is in the mechanism you must see either a positive charge or a delta plus in the first step of the mechanism for it to be classed as electrophilic addition. So the unsaturated part of the molecule attacks a full-blown positive charge on the other species, on the electrophile, or a delta plus, and that's how you classify it as electrophilic addition. So you will see on the two examples you have just crossed that there's question marks over the placement of where the molecule is going to go. So the reactant in this case is hydrogen bromide. So let's take a look at the first one, and then once I've explained how that works, then you can try the second one yourself. So as with any mechanism, first thing you want to do is add in all of the relevant dipoles and any other charges that are necessary before actually starting the mechanism. And remember, it's always for the direction of the arrows in any mechanism, the flow, the movement of the arrow must always be from something negative, a source of negative charge, to something positive. So a source of electron density to something that's electron deficient. Now I have explained this fully in another one of my videos, which I have linked below, so please go and check that out if that is unfamiliar. So with that said, let's get into this one. So we have the double bond and then hydrogen bromide. This is an easy one because the dipole is pretty straightforward. It's delta positive on the hydrogen and delta negative on the bromine. The reason why is because bromine is more electronegative than hydrogen. So just like I said, the direction of the arrow must flow from an electron source, something that's electron rich, to something that's electron poor. So the double bond attacks the hydrogen and that causes the HBr bond to break. So that goes through to this stage. So how do I know which carbon the hydrogen is going to be added to of the double bond? So if I use a blue to denote the two carbons I'm considering, it's this one and this one. Okay, so the answer is, if this is carbon number 1 and this is carbon number 2, the hydrogen actually bonds to carbon number 2. Which means the positive charge left over as a result of an electron pair being donated to the hydrogen sits there. Now, why is this? So the reason why is because what we have generated here is a tertiary carbocation denoted by a 3-degree symbol. And tertiary cations are more stable than secondary cations, which are more stable than primary cations, because that positive charge is surrounded by 3 carbons, 1, 2, 3, which offer an electron donating effect to stabilize the positive charge. So the positive charge is stabilized by those 3 surrounding carbons donating electron density towards it. So it's 3 degree is more stable than 2 degree, more stable than 1 degree. So if there's a choice between a tertiary and a secondary, or a secondary and a primary, the higher number always wins. So finally then, the lone pair and the bromide ion that's just been generated attacks the positive charge. So it goes this way. And then we finish with the molecule becoming completely bonded again, with that methyl group still attached and the bromine sitting on that carbon. So it's attached to the most substituted carbon. Okay, right. So what I'd like you to do now is, I've just done this one, example number 1. I would like you to try example number 2. And I want you to think about what I just said in terms of the intermediate being formed and cation stability. And then that will hopefully lead you to the correct answer for the product, of which you can check using the answer scheme below this video.